Okay, so like I was saying, before my camera ran out of memory, um, I'm not gonna have time to redo that. But basically, I was just saying that I don't even know what I was just saying. I was talking about something about I was getting off topic. Point is, let's see what we can do with this tech for nanophotonics. And let's see how we can apply this in a laboratory and what it can do for us. So let's take a look at this for a scenario. Large language model in a photonics lab, how can it be used? So one of the things that you can do is, because we're running it locally, we can we don't have to worry about being connected to the internet, right? So I'm using a tool here to run this locally. There's plenty of tutorials out there that you can view on how to set this stuff up. And you can use something like, there's all just different local clients. You can even write your own, right? You can just log into Gemini and ask it to make a local large language model client for you. We can walk through on how to do that. And the one nice thing about that is, if you do that, then you could be absolutely sure that there's no backdoors in your program going, sending off your data somewhere. Unless you know that you're going to be running your laptop in some Faraday cage or something like that, where your network to the outside world is completely cut off. Because open source software, it's great. You can read the code, but are you going to do that for every update that they do to make sure that they're not continuing to keep the software free by giving your data to some company or something? And not anything nefarious. It's just the fact that first publication rights, right? You have to worry about that. So so again, one of the reasons why to consider these local models. So let's just get the program to run, right? So the very first thing that we can do, let's see. So I can do. Okay, so I can list all the models that I have stored locally. And the one that I want to run right now is the Gamma. So we're going to do run Gamma 3 4B. So this is the 4 billion parameter model. Not going to get into specifics on that because I don't even know the exact specifics of what parameters mean. Let me rephrase that, because my PhD was on machine learning. In their specific use case, I don't know if parameters are referring to individual weights plus the biases, or if each parameter is considered a single neuron. So there's two values. So that's all I'm saying. I don't. So roughly though, the 3.3 gigs does translate pretty well into how much RAM it'll use for just the model alone. Your context window, which is basically the running memory, if you're familiar with LSTMs, that's like, not really, but it's kind of like the short-term memory in an LSTM. So let's see. So we want to run this model. So we're going to run, so we can ask it a series of questions, but the first thing that we want to do is maybe just, nanophotonics isn't like, it's pretty well understood, right? It's in Wikipedia and everything. So let's try to be a little bit more specific. What if I ask it, what is the relationship between me scattering, charge carrier dynamics, and scattering resonances, right? Like, that's something that kind of takes a few years for us to learn, right? So what is the connection? Again, this is local, not connected to the internet. What is the connection? And this has not been trained at all on any of my local data. Okay. So, and right there, we're just getting this off of our local machine. This isn't the fastest. I mean, this laptop is an M2. It's not the latest. Smaller models do run faster, but the smaller models generally. Gamma 1B, I found it's pretty good for basic interaction like this. But if you really need to kind of get into the technical aspect, oh, I love this. It even gives us our, it's even giving us the latest iteration of this program even gives us the Greek letters. Earlier versions of the software that I'm using would show the LaTeX markup. But yeah, so yeah, it's and the thing is there might be I found that hallucinations in technical material is very minimal. And it might, I don't know why. I don't know if the amount of data that Google used to train these models was more biased towards nanophotonics. I mean, they are a tech company. Or if it's got something to do with the fact that if you're asking it to write a letter for a story, right? Like if you ask it to make like a novel, right? There's a lot of these models are actually reinforcement based. So, and they also use boundary conditions to solve some of the problems. You look at the starting condition, you look at the ending condition, and you try to basically find the shortest path between them, or the most sensible path between them. And so maybe in context of when other people are trying this, who aren't in, doing actual scientific research, but are, daily users, like working at a corporation or something, where the verbosity of their, the context in which they're using is a lot less structured on mathematics and physical concepts than what we're doing. So maybe that's why it seems to, maybe that could also be another reason why we see less hallucinations. And the other thing is sometimes too that hallucinations, you have to be careful, right? Because I was in a lecture one day, sorry, not a lecture, a colloquium. We had this researcher come in, and he's like, well, this thing is hallucinating. Look at here. And he shows a big picture of, like, they were taking pictures of the ground from a satellite, and there was some clouds over the ground, and it was obscuring the ground, and they were like trying to read the ground. And he's like, yeah, this stupid thing is telling us that that this looks like a Christmas tree. And he's like, clearly you're looking at the ground, and I'm looking at this from the last seat in the in the auditorium, and I'm like looking at it, and the only thing I saw was a goddamn Christmas tree. It's perspective, right? It's like if you're not right in front of the information, you can't make out the small details. So when you basically are sitting further away, the less photons are hitting your eye. You have to, it's not a hallucination. A hallucination is something coming in your brain from nothing. That's called pareidolia. That's something completely different. and that's pattern matching. And it's when pattern matching fails because you don't have the right information to anyway, aside, getting tracked. But point is, these models actually don't hallucinate as much as people say in certain areas. I have seen it, but not here. And I've seen other cases where at first I thought it was hallucinating. Or you can maybe think, like one day I was talking about nanophotonics with it, and then it just immediately jumps into fractal